Okay, so thank you very much for inviting me. I'm very happy always to share with students and professionals alike the contents and give you a preview of my most recent book. And feel free, if anything is not clear, if you want to interrupt with a question, that's fine. And then we'll have a question and answer period at the end where we can go into more in depth. So the story behind the book is really, well, let me go back a little bit. The story behind the book is when I left the computer industry, where I had spent about 40 years running some of the largest UX groups in the world, as former chief design officer of SAP, former chief design officer of Oracle, et cetera, going back. I took on the assignment to teach an interaction design class at San Jose State University, which is in the middle of Silicon Valley in California, and to teach interaction design, which is my primary love and field. And I thought there would be some good books. And I was very disappointed that I couldn't find a book that really captured the methodology that I'm going to talk about today. So I promised myself that if I spent 5 years refining the classes on this topic for the master's degree program, that I would stop and write a book. And so I did that and took about 14 months of no consulting, just some teaching and writing the book. And it came out in January of 2020. So the story behind the methodology is, what is the first thing people are taught to do when you have to start a new interaction design? We're talking digital on-screen design, to say something like an application. And we have different approaches and methodologies and different design programs all over the world. But generally speaking, and this is a rhetorical question for you guys to answer, I will pause a couple times and ask questions. And there's not necessarily a right answer. But what were you taught to do? What do you usually do when you want to start a design? And by starting a design, let me clarify. Assume you know the requirements. Assume all your user research is done. You have a design brief. The problem is perfectly known, which of course never happens in real life. But assuming that you really knew exactly what it was you were going to do, what's the thing that most people are taught to do? I need a one-word answer. You can come off mute. I see somebody answered in the chat. Sketch, yeah. Mood boards are more for kind of visual design, but Sarah, yeah, gave me the answer I was looking for. You were taught to sketch, just start drawing. And many famous UX people historically, particularly Bill Buxton, for decades has been saying, just start brainstorming and sketching. And sketching's important, but I'm basically going to tell you, don't do that. That's not the place to start, okay? There's a better way. You will have to do lots of sketching. Do it later. So what is semantic interaction design? Well, it's basically a proven method that's based in solid cognitive science, and it's scalable to very complicated problems. And the goal basically is to be 10x better. And I'll quantify this a little bit for you later in some upcoming slides, but both in the quality, so again, efficiency and effectiveness. Now, I want to be very clear that I didn't invent this approach out of thin air. If you look at the field, the origins of semantic interaction design go back probably to Phyllis Reisner at IBM Watson Labs in 1979, and the notion of task-action grammar. This is before graphical user interfaces, but at this point in time, people were studying the relationship between different programming languages and command languages for users of computers and cognitive load. work in the UK by Spence and Apperly, etc. In terms of cognitive science, there are important milestones related to people who you've probably heard of. Don Norman's work on stages of action is kind of a foundation. Designed by Levels by James Foley, who's a retired professor emeritus at Georgia Tech, is extremely important. Professor Foley invented computer graphics, and that's not an understatement. He's Nobel Prize winning computer science. Activity theory from Bonnie Nardi, etc. And a book actually in 1995 by Dave Collins called Object-Oriented UI as object-oriented programming started. In 2012, Jeff Johnson and Austin Henderson published a book called Conceptual Models, which has the foundation layer, the grammar layer defined, not quite as completely as in my book, but I was using this book as a textbook because it did have the foundation to the method. For those of you who are unfamiliar with the term names, Jeff Johnson and Austin Henderson were on the original Xerox PARC team that invented the graphical user interface before all of you were born. Jeff is a professor at San Francisco University. Austin is retired. And this led to my book, UX Magic. And why the name UX Magic? Because there's this magical moment when you have to go from requirements to the first design. And so it's kind of a silly name for a serious book. Okay, so what's the value proposition here? I said faster, better, right? And so we want to be able to deliver digital designs with fewer iterations, less rework, fewer meetings and arguing, and particularly not making science-based trade-offs and not opinion-based trade-offs. So basically, for you to be able to create designs 10 times faster than you do now, and at 10 times greater quality, which would mean minimum number of screens, shortest flows, and particularly the lowest cognitive load being placed on the end user, and obviously ready to scale for the next version. So 10x is a very bold claim. It's an audacious claim. And in fact, the first chapter in the book is named Audacity. But here's some examples. When I joined SAP, which was at least 15 years ago or more, SAP had a customer relationship software product that had thousands of screens. And my team at SAP quickly reduced that to hundreds of screens. And then this was with the same legacy backend technology, but then did a cloud version with almost the same amount of functionality that only had 10 screens and then had an iPad app with 5 screens. That's over 100x compression in the number of screens to basically do the same work. Similarly, in my consulting, I have done a bunch of work in cancer treatment. And these are some ugly screens from a legacy product. It frankly looks like old legacy SAP, but this is for radiation cancer treatment, electronic medical record system. This was a client of mine called Varian Medical Systems that makes radiation cancer treatment machines and is now part of Siemens. It was purchased last year. And that's the old design. And here are a few of the screens from the new cloud product, not so new, it's been out for a few years, where we went from about 800 to about 45 screens using some modern design patterns and some traditional ones. Now, in this case, the improvement could be claimed to be about an 18x reduction in screens, but that's actually an understatement because the original product only dealt with radiation cancer treatment. The new product dealt with chemotherapy, surgery, and genomic treatments as well. So in this case, 18x less screens, a 3x increase in functional capability. So when would you apply this method? Well, at the heart of the user-centered design lifecycle. So one of the main things that's quite important to understand is my work is really only focusing on the actual design process, detailed design doing interaction, right? The other phases in terms of user research, before and after, are very important. And if you don't have good requirements and good user research and understanding and personas and journey maps that are accurate, of course, you will come to this phase and it will be garbage in, garbage out. So you might have a usable design, but it will be for the wrong thing. So not to forget the whole picture, but this is a specialist lecture. Why was this necessary? Well, there's this prevailing and going away finally idea, particularly here in Silicon Valley, called design Darwinism, which is that you just try stuff. Startups try stuff and see if it sticks. Well, it actually doesn't work. It's a kind of a stupid method where we've got dependent on A/B testing of websites and things like that. And honestly, the click-through data does not imply causality. So, and particularly in my work with medical products or aviation or big industrial systems, you can't A/B test and see how many patients die, right? That's not a viable approach to designing software. So real quality is always achieved by having good design, not by putting out crap and then trying to eliminate the defects. So how do you do this? So I'm going to break the how into the theory and the practice. The theory is actually fairly straightforward. There's 2 cognitive science principles that I'll speak about in a minute, and there's 4 modular levels of design that you have to deal with. The modular levels are the grammar layer, the visualization layer, the flow, and then optionally game theory. And I'll spend most of my time today on the bottom 2, but I'll touch on the upper 2. The cognitive science actually can be reduced to 2 things. We know that language, spoken language, natural language, is the basis of conscious thought. It's not the basis of all human thought. In the primitive part of the lizard brain, right, not the frontal cortex, we have the emotions of fight and flight and our amorous intentions. But if you have to solve any kind of puzzle, you are going to use the frontal cortex of your brain, the new part, and you are going to use whatever your mother tongue is to think through the problem and do the analysis, right? And so the simpler the language, the better, because we know from decades of research in both natural languages and in computer programming languages that language grammar correlates with cognitive complexity. And we know that cognitive load can actually be measured in a usability lab. If you don't know how to do that, you can ask in the Q&A. But what I'm telling you that's new is cognitive load can actually be predicted in advance without even drawing a screen and showing it to a user. How would this work? Well, let's look at graphical user interfaces. Going back now almost 3.5 decades, graphical user interfaces were invented around the concept of a grammar of actions and objects. We would tend to see actions in pull-down menus or pop-up menus. Objects are things that we manipulate. They can be abstract, or in the case of a graphics product, they can be quite physical, like a box or a circle. And all objects have a set of attributes. In this case, visual attributes, but in the case of an enterprise software application like SAP, there will be lots of data attributes. And we know, basically, that there is a relationship between consistency and cognitive load. So for example, I did some early work on word processing software, actually 3 of them over the course of my career in different companies. And if you were to take the idea of a word processor, you could say the objects that you manipulate are characters, words, paragraphs, pages, etc. And if you had a very sloppy grammar, so with a lot of inconsistency and redundancy, you would say, okay, well, I have a command for cutting out a character, but when I get rid of a word in a document, I would have an action called remove. And again, I could have copy for some and duplicate for others. And you basically get what's called a sparse grammar, right? So a lot of places that are null and a lot of inconsistencies, and sparse is bad, right? The invention of cut, copy, paste, specifically by Larry Tesler, excuse me, who passed away last year, was also part of the Xerox PARC team that invented the graphical user interface, said we can reduce this to the tightest, most symmetric relationship between actions and objects and have a dense grammar, and this would be easier to learn and faster to be actionable, and would result in fewer screens. Now, for those of you who have not read the book, okay, I'm going to pause and ask a question. What is the difference in cognitive load between that sparse matrix, the sloppy grammar design, and a perfectly dense one like this? Okay, so I'm sure you'd all thinking, well, obviously the dense would have lower cognitive load, but what does the math look like? Anybody want to say how much worse is the sparse than the dense? You can come off mute and throw out a number. Or I can look for the chat if I can find it. It's hard to see. Okay, so in the chat, I have 100x and I have 3x from Kristen and Ida. Okay, all right. So here's the math. 100x is more accurate. So modulo a few coefficients that should be included if we had a PhD in cognitive science, from an engineering perspective, this is good enough. If you had a perfectly dense grammar, cognitive load would grow linearly as the number of actions plus the number of objects. As you get sloppy at the semantic level of your interaction design, you basically get exponential growth, and it becomes approximately the number of actions times the number of objects. So you get into a pretty bad situation pretty quickly. And so you can imagine how we could have thousands of screens and get it down to tens of screens is by crushing the grammar down and making it incredibly consistent and symmetric and simple. What is the inflection point here? Because there is no perfectly dense grammar, and I'll show you some in some case studies. It's about 20 or 30% white space, right? Every action is not going to apply to every object in a complex system. So what did it look like in that electronic medical record for cancer treatment? This is the grammar. So basically about 8 objects: patient, a medical record, the treatment plan, which is looking forward, the medical record, which is looking backward in time, and then a few operational things like appointments and tasks and messages, and then the care team, because you have many doctors when you have cancer that have to coordinate, and that's the actual purpose of a product like this. And then you have some pretty straightforward actions, like creating some data, updating. You void, you never delete anything in a medical product. And because there's workflow, you have to accept and reject and sometimes delegate tasks and to have some approvals and things. So it could even be simpler than this in retrospect. So that's a real grammar, and we'll look at screens periodically throughout this talk from that system. So now if we come back to the practice, let's really learn how to do this. Okay, the grammar level's where we're going to start, and then we go to visualization, where we're interested in design patterns, flow, where we're interested mostly in flow, but the topic of micro interaction design, if you're familiar with Dan Saffer's book on the topic, would fall in this layer, and then game theory, which I'll talk about later. So grammar. Where do objects come from and actions come from? Well, if you go back to natural language, they come from nouns and verbs, right? It's pretty straightforward. And then adjectives form the candidates for attributes. And the high-level process view is define the objects and actions, figure out all the attributes for the objects, and prioritize, because not everything is of equal importance. So another case study that I use in the book and my classes is a hypothetical nonprofit for rescuing dogs. And just for the record, I don't have a dog. I'm not a dog person, but it's an easy one to understand. And so if we looked at the user stories, right, that would define the requirements for a pet rescue, I could say, as a parent, so person object, I want to find action, a friendly attribute, dog object that will help teach my children, person object again, to be responsible. As an elderly widow, person object, living alone, I want to adopt action, a dog object for my protection attribute. So it's as simple as if you write out the millions or hundreds of user stories that would define the scope, you start by foraging for objects and actions, and literally you can just use colored markers, right? Eventually, you will get to a matrix of possibilities, and it will be kind of large and sparse, and it's going to be very sloppy. And then you try to pivot in two ways, right? You try to figure out the minimum number of objects, and you try and figure out which actions can be portrayed in a graphical user interface as the state change of an attribute. So that would mean instead of having a publish action, you might have a slider in a screen that says publish yes, no, right? And we'll talk about why you want to move everything to be attributes in a minute. So if we looked at a scalar calculation of cognitive load, if we based on this grammar, it would be 66, right? It's an approximation, and here it would be 9, and you can go further. And so basically, very quickly, you can get to about a 7 or 8 factor improvement, or basically 14% in the number of screens. Now, students, like Svenja, who did this in class, we actually do this exercise, and we take the Silicon Valley Humane Society website, which has about 225 screens, and we actually redesign it as our first project with additional scope. And on average, students can redo the whole thing in 20 to 30 screens with a more usable design and, again, additional scope that I add. Okay, so it's kind of that straightforward. Now you have to figure out all the attributes, right? So an animal, of course, would have a species, an age, a breed, a health, and a personality necessary to match it with a person. But what's most important to understand is attributes in regard to natural languages do not add significant cognitive load. Attributes, particularly in a graphical user interface, rely on recognition type of memory, not recall. And so it turns out the more you can pivot the experience to reflect things as attributes, and all content is really an attribute, the lower the cognitive load. Human beings are the best pattern recognizers of attributes and attribute hierarchies and categorization. So all of you could recognize an animal as a dog. The breed could be one you've never seen before in your life, but you can do the pattern matching to say, that's not a cat, it's a dog, right? Even though you've never seen that kind of dog before. Then we need to prioritize, as I mentioned, because not everything is of equal importance. And we have two dimensions to consider. One is what's important to the user, and the other is how the business makes money, particularly if you are making money by having people click on the screen. And the dimensions that one would prioritize against are basically frequency, how often people do that action, and how many people do that action. So for example, frequent by many might be purchasing something. Frequent by, but rarely by many would be to install a piece of software or to create an account, right? You only do it once. That doesn't mean it's not important, because you might never get any money from that user if they don't create an account. But again, it's not a high frequency task. And so if you understand just this grammar layer, all right, and the math in terms of cognitive load, there's 3 things you could take away and use right now without even reading the book. Number 1, this is a very good heuristic evaluation technique. You can assess cognitive load of an existing system and find the mismatches between the user's mental model and the actual UX that's being communicated, because the conceptual model is the designer's idealized view. This is the language that you are creating as a designer and trying to map to the a priori mental model that users have. If you're going to design a new project from scratch, this is the clear way to minimize screen count and complexity and get the job done with higher quality and faster than any other technique. And you will save a ton of time by doing the prioritization of your object action pairs, because that's what a task is, before you start drawing stuff. Often UX designs, the first 10 sets of sketches are just arguing about prioritization and what goes where, right? And then you throw them out before you can even get to the kind of on a track to a viable commercial design. Third, if you are evolving existing products or websites, which is the majority of work, though for me, most of my work is net new. But if you're doing evolution, add features, any new capabilities, attributes of existing objects. And that will minimize the cognitive load as your existing product or service continues to grow and you have feature creep. Now, we go to visualization. You blow the visualization layer up into design patterns. It has its own hierarchy ranging from the simplest components of buttons and labels all the way up to architecture, and archetypes are page patterns. And the main thing here is, now that you have a grammar design, are you picking the best visualizations and making sure not to use visualizations inconsistently? Let me now talk about my terminology for a minute to help you follow me. Okay, when I say component, we're talking about the raw, most primitive pieces of graphical user interface, which are pretty much buttons and labels. If you assemble them into a grid, it starts to look a little bit like a calendar, and so we would call this a widget, right? If we start to add date changers or month changers, et cetera, it's a little bigger widget, but eventually this pattern grows into an archetype of a full screen, which you would recognize, whether it's Outlook or Google Calendar or a calendar in a medical product, right? Users will recognize the pattern. They'll expect filters. They'll expect a whole bunch of other things. And they come with those a priori assumptions about behavior and semantics. Okay, so let's look at components. I'm not going to read you the whole table, but the basic thing to understand is that components, for the most part, were designed to represent attribute values. Only a few things like a button or maybe a hypertext link were meant to represent an action and an icon, okay? And again, I have put an X here for what I would say is the primary use, and a small x maybe for a secondary use. But the important thing would be that as you're designing a product or an entire system, you get rid of half of these X's and say, okay, we are only going to use hypertext links, for example, to navigate. We're not going to use them for as equivalent to buttons, or we're going to use them consistently, and we're never going to use buttons for anything but an action, right? Or what are we going to do with these controls? So we're not messing with them doing multiple things. And I'll talk about menus in a minute specifically, okay? So if you have to use a type of control for two different things, then it has to be visually distinct. So here in LinkedIn, for example, we have a menu screen, but it's a menu of objects, because in LinkedIn, right, jobs are a primary object. It's LinkedIn, if you think about what the objects are, it's pretty much jobs and people, right? Maybe companies. Here we have an action menu in LinkedIn as well. And we're okay with this. This causes no cognitive load because this action menu and this object menu have the same visualization. But can you imagine if, for example, they did something stupid and used this cards widget layout for the action menu in addition to the object menu? Now we're going to have some serious collision and confusion. So changing, keeping the visualization patterns different is good. Using the same visualization pattern for both objects and actions would be a significant semantic error. let's talk about an example of a semantic error. One of my favorite candidates for errors is Yelp. And I don't know if people use Yelp in Germany or if it's just a US product. There's probably an equivalent of these social review systems, right? So Yelp is all about finding restaurants and other assets, services. And here in this design, we have the tab control misused, right? So the first tab in the messages section is inbox and then maybe sent messages, but now the tab control is an action button called write new message. So this is the wrong use of the control, and it's in the wrong place because it looks like it's one of the tabs, but it really should be separate in a different location and a different selection of control. Now, you might think this is a minor mistake, but in a medical product, this is how patients get killed, right? And I'm not exaggerating. If we go to widgets, there's lots of widgets when we start putting those controls together, those components together, and we have tables and grids and cards and all kinds of pickers and wizards and property sheets. And again, here, I'm saying these, I'm kind of indicating what I think is primary usage that would be recognized by the majority of digitally literate people. But again, you would get rid of half of these in your design system and say, we're only going to use cards, for example, for objects. We're not going to use it for anything else. So again, don't use trial and error. Don't use your intuition. Make a very conscious decision how the widgets will visualize your grammar. And I'll show you another mistake. And this one is in the Google material design. About 6 months before the book came out, the Google material team heard about it and asked me to come give them a private preview. And I was quite familiar with Google material because we used it in the cancer treatment system and had to make a lot of changes in it because it is sloppy. So an example is in the card control, right? Material says put the local action button in the lower left corner, and it has a specific style. But reserving, here we have an object card, and reserve is a transactional action, right? Money is going to change hands. Here we have an attribute card, and expand is not grammar relevant, it just opens the card. Again, seems like a minor semantic difference from a neurotic professor, but again, patients die when you have these kinds of mistakes and inconsistencies. Expand doesn't do anything but change the view. Now, you will note that there are a lot more widgets and controls than I had in my tables. And you have to understand when widgets are not grammar relevant. So for example, a dialog box is neutral. It's like Switzerland, right? It doesn't have its own grammar, right? It takes on the grammar of the things you put inside it. The same with a toolbar, right? And controls like zoom, pan, and scroll don't matter because they don't move the interaction flow forward in terms of completing a transaction. And then you go up to the archetype level, and archetypes are page patterns, whole pages that people would recognize, like the desktop on your computer or your phone, a catalog like when you're shopping, or tool and canvas when you're doing something creative. Could be anything from Sketch or Figma to PowerPoint, and then dashboards, etc. And again, I have a lot of X's here. I would get rid of 70% of them if I was designing a solution and say, we're only going to use this pattern to do a certain type of thing in the grammar. And I'll show you some case studies. But let's take one apart. Okay, if we take apart Facebook, and this is a slightly old screen, but you can see there's a pretty simple grid, but there's global actions in the header. There are local actions like join and this plus to create a story. In Facebook, basically the objects are people for the most part, and content again is just an attribute in the feed. And you would tend to have this feed widget running down the center of the page in any social archetype pattern. And there's where Facebook screwed up. And I know they've changed this, but the new design is just as bad, where with the exact same visualization and style of icons, they're mixing objects, actions, and attributes. and then have yet another way of doing some action attribute-based creation with a slightly different visualization. So this is really sloppy. And this accounts for numerous redesigns, which Facebook keeps trying to do this panel over and over again, and they never get it right. And one of their lead designers happens to live across the street from me, and I complain to him about this whenever I see them. Okay, what does it look like when you put it all together, right? So that was a kind of static view. So let's look at now having a tight grammar and expressing it consistently across all of your decisions. All right, and so here I'm going to take you on a day in the life tour of an object and an action, and again, how to be consistent. So let's start with something simple. Let's take the appointment object and how it was managed with high semantic consistency, both in visualization, right? We don't need to know much about the practice of medicine. So here is that homepage where we had a swim lane archetype with cards. And in this case, it is heterogeneous because each lane has a different kind of object, but we're just going to look at the appointment one and keep it simple, keep the rest out of here. So the appointment is an object, it's on a card. You click the card expands. What you interestingly see inside the card is, in addition to the appointment attributes, there are attributes about the patient. So you can mash up the data to make this really useful for people. Doctors really love this, particularly in the mobile version, because when they're running from consult room to consult room and doing 30 patient consults a day, they can look at their calendar, see where they have to go, and get the latest diagnosis and status on the patient inside the appointment. Every card in this design system for this EMR has a local action menu that's context specific to the object and to the persona. So for the doctor, the main action is to create a task. For a nurse or a technician or the front desk, right? If we look at the calendar pattern in the EMR, the main user is the front desk clerk, right? And of course, this would be full of all the doctor's appointments, but and the entire clinic's appointments, so it can be pretty messy. But again, the same design, but the local action menu is optimized for the clerical persona, who generally would cancel appointments and reschedule them. If you get into the patient chart, the appointment object is sitting on the summary page of the patient's medical record. It's called the chart. And a few things have changed because now this screen is all about Josephine. We don't need to repeat the header information, and all the local actions can now be global actions. And there's an entire section in the book on understanding the usage of actions, the anatomy of actions, and when they're local and global in your semantics. But again, same activity here of manipulating the appointments. Now let me go on to the void action. So let's look at an important action in medical, okay? You do not delete data in a medical product. That's against the law, both in the EU and in the US. You void it, so you would scratch it out. So here I have a quiz question for all of you to look closely at the header of this screen. All right, so we're going to look at handling errors in a medical product. All right, and who can tell me what the medical error is in this screen? You do not have to go to medical school to figure this out. And I can't see if anybody's put anything in the chat for some reason. Here we go. Not yet.
Yeah,
So somebody
is
Yeah.
go ahead.
I think the diagnosis on the top says something about prostate cancer.
Yeah. And this looks like a female patient, right?
Yeah.
Okay. So let's assume who caught that? That was, what was your name?
It was me, Kristen.
Kristen. Okay, thank you, Kristen. Okay, so we will assume this is a medical error. If Erna had gender reassignment surgery, this would not be a medical error. in a male to female transformation, you still have a prostate, but it's in a different location. But we're not going to go there today, okay? We're going to just assume this was an error. Somebody coded the case wrong, an intern or a fellow who didn't get enough sleep. So what would you do? Well, this card represents the diagnosis, so you click void diagnosis, and normally you don't want to see them. So what would happen? It would be struck out. And of course, there's a filter here. So you could see what was voided in the data. This is really only for forensic purposes. If something happens and you need to investigate. So normally this box would never be checked. So we strike it out, we uncheck the control, and we're done, okay? So we got rid of that, and what we really have is breast cancer in this case. If you click the staging, the cancer diagnosis card, of course, you have a lot of dense information, and this is very hard to make this simpler. But I want to point out that you could void the entire diagnosis, or during staging, you could make a mistake in clicking any of the values for the modality and the number of nodes and any of the pathology. So you would also have the include voided behavior at the local level. You made a mistake and you came back an hour later, or you got a new pathology report. So you don't have to throw out the whole thing, but you do have to record when you made a change. Okay, so again, global and local behavior for the void action needs to be designed. Very quickly, if we go into just documents, somebody scans in an incorrect report for a different patient, okay? Again, we need to be able to void it. Same behavior. The journal is where doctors and nurses leave free-form notes for each other. Again, if you make a note, but you realize you were talking about a different patient and you've saved it, right? You have to void it. And you note that once you void a comment in the patient's medical record, there is no undo, right? You would just, you'd void it. If the box wasn't checked, it would go away, but you would have to type it again. And finally, when you put all of this stuff together at the highest level of architecture, and here we overlap slightly with the topic of information architecture, is assuming each of these boxes is a screen, so and has a page archetype, there are different ways in which you would choose to organize the architecture of an application, right? And websites are often hierarchical. A shopping cart checkout flow or a tax return product is going to be fairly sequential. And then there's the matrix, the network, hub and spoke you see a lot on journalistic sites. I'm not going to go very deep on this, but there's quite a bit in the book about different architectures. And every one of these 5 architectures has a bunch of human factors characteristics like learnability and efficiency and location awareness. So for example, in a serial flow, a set of screens, you'd have very high location awareness. In a network location where any screen can go to any screen, you would have a fairly low situational awareness. The main reason I included this in the preview here is the grammar and architecture are sensitive to each other. If you move to the matrix or network, you have to have very few objects or this becomes a mess, right? And so that in the medical product that I showed you, we actually looked at hierarchical, hub and spoke, and network. And we refined 3 different grammar proposals for the semantics. And they're slightly different. They're 10 or 15% different. So there is an interaction for this very top level, almost information architecture, and how you might manipulate the grammar. And there's no right answer. They could all be valid solutions. So now that I've kind of crammed in a lot of information here about design patterns, who understands design patterns? And the answer is actually 5 billion people. All of you do, because you're probably digital natives. But you come to every one of these patterns of widgets and archetypes with a priori assumptions about how it behaves, what would represent an object, what would represent an attribute, and what would represent an action. Interestingly, the other 2.7 billion people on the planet can only come into the world of human-computer interaction by understanding and mapping their knowledge of the physical world into objects and actions that they see on the screen. And if you've ever had to teach an elderly parent or a non-native, digital native how to use a computer, you will be sitting there explaining it with nouns and verbs to them. That's the only thing you can explain. Now, there's one exception here, which is how pre-literate children learn to use computers. We'll set that completely aside because children can actually learn to use computers before they're really linguistically competent. But adults, once you speak a natural language, this is the only way you can see the world. Flow. I'm going to be very short here because I want to leave time for questions and answers. Okay, the main thing to understand when we move up the triangle to the flow layer is actions propel the task through the objects. It's really that simple. Okay, if we were to take the grammar for the simple pet rescue, right, and we want to take the donate action, how would the donate action, which needs a dog, it needs a potential owner, it needs an organization to host the dogs, and it might involve some money to pay some fees, how would that work? And here we're going to use very simple boxes and arrows. And I use the interaction flow charting system designed by Jesse James Garrett 30 years ago, and it's still on his website. And essentially, it would look like this, right? When we might be on the home screen, we see a donate call to action button. It takes us to a donate screen. We might have a side trip to a volunteer screen because volunteering is also a form of donation. And eventually, you would get to some kind of thank you screen. So what action moves us from this screen to that screen? The donate one. And then the pay action moves us. And there are different objects involved, right, along the way. The organization is thanking you, not the dog. And then we would have some flow decisions maybe based on the member status for what to do with them after we thank them. And it's really that simple. And if you, what I teach and what I practice, and I do still do a lot of design work, is figure out the grammar, then figure out the flows without going to the visualization layer. So actually, I'm teaching it to you bottom up, but I actually go grammar. I take the top priority objects and actions, and I do the flows theoretically. I do not have detailed screens. And then come back down into the visualization layer. So in practice, you bounce around a little bit, and then you keep refining and iterating. Okay? And finally, we get to game theory. And the question with game theory is, can you motivate human behavior to favor a specific task? Again, where a task from a human factors perspective equals the combination of an object and one or more actions. In the field of game theory, when you apply it to interaction design, there are three flavors. There's gamification, which is the addition of reward elements to incentivize work. Gameful design, which is the substitution of a proxy game, but when you complete the proxy game, you've actually completed the task. So it might think of a model where you look like you're playing Tetris or some computer game, but when the puzzle pieces fit together, you've actually filled out an expense report. And I actually had a student who tried this and did her thesis on it and came up with a very clever design that looks like a puzzle, a jigsaw puzzle. But when you're done, you basically get reimbursed for your trip. And then captology, which is using computers as persuasive technology. This is the work of B.J. Fogg at Stanford, how to persuade people to change their behavior. And the relationship of game theory to what I've just taught you about conceptual models is in the gamification flavor, you're basically providing action incentives. In the gameful design approach, you're doing an object substitution. And the captology or persuasive design focuses on manipulating attributes and nothing more, right? So when you see on a shopping page, only one available at this price, right? That's an attribute manipulation. Someone's adding additional information to lie to you and tell you that there's only one left when in fact the warehouse is full of them. And they're trying to persuade you to act now. Why do we use game theory in interaction design? Generally, we want to increase some human behavior, could be productivity or satisfaction, or we want to decrease something, could be errors, could be energy consumption, whatever, right? But generally, we're trying to increase or decrease some human behavior, and we are leveraging two classes of human motivators: intrinsic motivators like love, belonging, autonomy, versus extrinsic motivators such as fear and greed. There are many good examples, but whenever you look at one, and this is one from the Nissan Leaf electric car owner's portal, and this is a game where everybody in the United States and everybody in Europe and everybody in Japan and Australia are competing to save trees, and a tree equals a carbon offset, okay? And it's a collaborative game, and you basically are, in this case, using a competition mechanic, or competition motivator, excuse me, and there are a number of game mechanics, like connection, feedback, and narrative. So the way to map the game theory literature to what I've just taught you is a game mechanic. If you look at Amy Jo Kim or Gabe Zichman or any of those people, a game mechanic is basically a combination of a page archetype, like a leaderboard, and a flow. So all of designing games is a combination of archetypes and flow patterns. This is all around you, and this is a legally acquired slide on how Facebook manipulates you. I assume many of you are Facebook users, and Facebook intentionally introduces social pressure, unpredictability, and scarcity. And these are the mechanics and design elements in Facebook that are used by the design team to get you to stay longer so they can make more money showing you advertising. At the same time, not all uses of game theory are evil. I use it mostly in patient-facing applications. This one is for diabetes management, and it's a product called Blue Star from a company called WellDoc, and it's for managing now type 1 and type 2 diabetes. And this product is legally a pharmaceutical in the United States, and it's available in Japan and India now. I'm not sure if it's in Europe yet. And for type 2 diabetics, high-risk type 2 diabetics, using this solution in clinical trials has been shown to reduce their A1C, the blood glucose level, about 2 points, which is better than metformin, which is the leading pharmaceutical. So here we have basically a patient-facing solution, like a buddy system, using game theory that can outperform the leading pharmaceutical. And it is by prescription because it can dose insulin. So again, there are safety issues in this product. So you can use game theory for positive uses, though most of them I would say are probably not. So that's the end of the book preview. And a few other subtle points. A reminder, again, it's all about design doing, not like abstract design thinking. It's really design to produce. And don't forget the other design steps, but I'm not going to talk about them. There's more in the book than I've talked about. We've kind of gone through the first few chapters, but there is a chapter called Elegance, which is purely about graphic design. So even getting your visualization patterns and saying, okay, I'm going to use a dashboard or I'm going to use a wizard, all good. But if you screw up the very basic graphic design, it will make the semantics less intelligible. Then there's a chapter called Myth, which is about style guides and design systems and the interaction between the grammar layer and how well it's being supported in the design system. The best one out there in terms of having semantic content is actually the SAP Fiori. And SAP Fiori was designed and implemented long after I left SAP, so I can take no credit for it at all. But it's actually the best, but it's still weak. The ones from Apple and Google are actually quite weak on semantics. And then Chess is just a very short chapter in the end about how all of this goes forward with the future of design and the design profession when you take the semantic approach, and you can basically figure out the cognitive load in advance for everything that you're doing. The publisher is the Interaction Design Foundation, which is a nonprofit in Denmark, which I hope most of you know about. It's a very, very good resource and one of the few actually well-curated resources on interaction design compared to most of the stuff on the internet that's garbage and wrong. And you can just get the book through Amazon. You don't buy it directly from the publisher. And there are exercises in the book. And there are exercises if you join the Interaction Design Foundation. It's a very nominal fee that would take you kind of through do-it-yourself through the first semester of my class. And this probably doesn't apply to you guys. I do actually have the material, maybe it would be another lecture or two for your university, on how semantics works in data visualization and information architecture. I chose not to put it in the UX Magic book. The book is already 400 pages in full color. It would have become an 800-page book. So these are probably future books, but all the information exists to deal with these orthogonal dimensions of design. And that's kind of the end.